No.
Okay, we're live. So, question number 3, since the first 2 are always the same.
Mm-hmm.
In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others.
True.
Yeah, I would say so.
Yeah.
Okay. What requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply. Sample means are all positive. Data in each group are normally distributed. Variances are equal in each group. Well, data in each group are normal. Like the second for sure.
Yes.
Mm-hmm.
And there was another one. Are equal in each group.
Yeah, and the third as well.
I think the third one. Yeah.
Third one.
Yeah.
Third one.
It's the one that is checked that
Yeah.
the variance, like the highest variance, has to be maximum 4 times like
Yeah.
the lower.
Has to be
Okay.
less than 4 times.
Well, yeah,
Yeah,
it can
less
be
or equal.
maximum
Oh, yeah.
to 4 times. Yeah. So we're saying the same thing, just looking at 2 different angles. Yeah.
Okay.
Okay.
Question
would you like
5.
to? Alright, just go from you. Who cares?
Okay, sorry. To check if each group is normally distributed, do the following: construct a scatter plot. Blah, blah, blah. I think the third one, construct QQ plot for each group.
Yep. Construct the key.
Mm-hmm. You could block. Mm-hmm.
6, we assume the variance in each group is the same if the following happens: the sample variance in each group is smaller than the sample error. No, we said that before. Okay, the second one, the largest variance is less than 4 times the smallest variance. Okay. Question 7, another hypothesis test is equivalent to conducting independent 2-sample t-test between every pair of sample. If there are 3 samples, there are 3 pairs, 1 and 2, 1 and 3, 2 and 3. How many pairs are there when there are 4 samples? Will be
6.
Yeah, I didn't get this very well. I
yeah,
it,
6.
So can you explain that to me real quick?
I just do. So there are 3 options between 1 and 3. So there are 4 options between 1 and 4, right?
Okay.
So 1 and 2, 1 and 2, 1 and 3. Oh, sorry, 1 and. Oh man, I'm so confused. So if you have 4 options, you will do 1 and 2, 1 and 3, 1 and 4. So you have 3 options, right?
Okay.
So I'll just do 3 plus 2 plus 1, because every time you lose 1 option, does it make sense?
Kind of.
Okay.
Well,
Makes sense is my mind.
what he's trying to say, he skipped one little bit, of information. Is that if you try to imagine to make a table, and you have 1, 2, 3, and 4, you have to check all different pairs. So you do 1 and 2, and that's 1. 1 and 3, that's 2. 1 and 4, and that's 3. But then you have, so those are all the combinations possible between 1 and the other 3 samples that you have.
Okay.
Then you move to sample number 2, and you check which pairs you haven't formed yet. You cannot do 2 and 1 because you already did that, considering 1. So you do 2 and 3, 2 and 4. So then you go to sample number 3, and you don't go upward because you already did 2 and 3 and 1 and 3. You just do 3 and 4, and that's the 6th one. So what he was saying is that.
I was following you here. So basically just like that.
Yeah, exactly.
Okay.
So what he was saying is that if you look at it mathematically, if you have 4 different options and you're taking the first one, you will have 3 combinations possible. If you take the second one, you always have 1 less,
Combination.
The second has 2 combinations, and the third one only has 1. And so you come up with 6.
Thanks, guys.
I see myself twice too.
You like it?
Well, I have a cool picture, better than my face. Okay,
Yeah,
so we agree on 6, right?
Yeah, yeah.
Yes, yes.
Okie dokie. Oh, Daniel, you can read. Someone can read the 8. It's too long.
Yeah, the data in soccer shoes is collected to help determine how the design of soccer shoes affects the accuracy of kick. There are 5 shoes, A, B, C, D, E, and socks. So there's 6 groups total. Each row represents a kick from 10 meters away. Anyway, from a target was hung 15 away from a target that was hung 15 meters up from the ground. The column accuracy is a distance in centimeters from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. I have a number for this one just because I wasn't sure how long I'd be here. So
Okay, just a second, you know. Let me. Gabriel,
Yes,
put that thing on silent, you know.
I am doing it right now.
It's kind of annoying.
Whatever. You don't appreciate my ringtone.
oh, it's a ringtone. Do you guys play a lot of soccer?
Not really that much right now.
Yeah.
No, we have never been too much into soccer. You know, like we like it. Personally, I like almost all kind of sports, so I like playing it. But it's been a while since I played.
Daniel, are you using the normal probability app, please?
No, why?
I don't know. Just I was seeing that it's like, oh, if you need, here's a link to blah blah blah.
No, I have not. I'm just copying and pasting all the data.
Yeah, me too, but I don't find the file right now.
It's annoying when they put, you know, like all these different.
Yeah, I don't know why they don't just do it in a row.
Yeah, exactly. You know, it's like usually it is, but like when it's this way, it takes so much longer.
Yeah,
It's just a waste of time.
That would be annoying.
Nova.
Okay. So, what was the question again? What is the minimum variance for the 6 group? Do you get 27.208?
Yes, for the minimum, I got that one. And for max, I got 53.
Wait a second.
158.
That's the maximum. 53.158. Yeah. That's what for my brother.
I'm still copying.
Uh-huh.
Wrong one. Okay, sorry guys. Thanks for your patience. I've been breaking tiles with a hammer the past hour and a half, so my hands are quite like sore. Okay, there we go. So, So what is the question? Where are
What's
you
the
guys?
maximum variance? Oh, there's minimum and
Okay,
maximum.
maximum. 53, 158. And the lowest one is the minimum, smallest variance of. Yes, okay. I agree with you guys. Question 10. The test for equal variances is satisfied for this data. The test. What does that mean? The test.
So isn't it the one thing where the max cannot be, there has to be 4
Oh,
times less
yeah.
Yep.
than the minimum variance?
Yes.
Yes, it is.
So true.
Yes.
Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. Each of the samples are approximately. Oh,
I have already done the first 2, and I'm doing the third one.
Yeah, exactly. So if the one is wrong, then they can't be right, you know?
Yeah.
Because this is each of the samples, so I just.
haha.
Yeah.
Good job.
So,
So
I'm
false.
doing what? False? What?
Right? It says each of the samples are approximately normal based. If one is
Well, we
wrong,
have to check. We have to look at them and see.
Oh, I thought Isa already found one that was not. Haha, just kidding though.
Wait, have you gotten that they're all normal? So far?
I am doing it right now.
Oh, okay.
Have you already done that?
Well, I thought I did it, and it looks like none of them are normal.
Well, they're kind of normal.
Really? Okay, maybe
Because-
I'm putting in the wrong standard deviation or mean or something.
Because it says that, you know, they don't have to be like perfectly normal. There's only one up to this point that it's making me think a bit more about it.
Which one is it? Which number?
The second group.
Oh, my Excel froze.
Yeah, see, I dropped the data into the histogram or the QQ plot, and it looks like all over the place. Like,
But because you have to then sort the column from lowest to highest.
okay. That's what
Yeah, they kind of look normal. The second and last are a bit more off the line, but I think it's nothing major.
Oh yeah, I see what you're saying. Yeah, it does look normal. Okay. I guess it could be true then.
If you just want to look at the second and
I saw the second one. It doesn't look very
yeah, it doesn't look too off.
off now. It looks normal.
So, okay, let's say true. Also, because this is the same example that's on the textbook, so
Okay.
I don't think they put on the textbook something that doesn't follow the normal distribution. So are we good to go with question 12?
Yes.
Yeah, I got. Do you want us to say it?
No, I'm reading it right now.
Okay.
So perform an ANOVA test in SPSS and observe that the p-value is 0081. Then remove the sock set and perform the text again. What is the p-value when we remove blah, blah, blah? We change it a lot. It's like 0.309.
Wow.
Yes.
Yeah.
That's what I got.
Question 17. The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left? Right.
Mm-hmm.
Yes. The right.
Yeah, because it's right skewed. So. Well, it's interesting, you know, because like if we were to keep, you know, like the SOX data in, we would reject the null hypothesis, you know. But like if we take the SOX out, we can see that there is not much difference between different shoes. It's cool.
Socks are making a big difference in life.
All right. So researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat. Mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, calories, and the sodium level. Their data is available in the file. Use this data file to answer the remaining questions. All right. So. Let's get that file.
So do we need to copy and do the same again?
I don't know. Let's see what it's asking. Let's examine the calories first. Construct QQ plots of the calories of each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met. Okay. So there's a little work to do.
Calories for beef. Daniel, I can copy that and you can do a QQ plot if you want.
I'm doing the QQ plot right now.
Okay, I am ignorant, but what's the difference between beef and meat?
Beef, it's like
Beef.
Cow.
And
And
meat?
like meat, it's general. You know, it's just whatever meat you're eating. Like,
But that's not specific.
well, that's why it's written that it's a mixture. Okay. One QQ plot done.
So
Oh, lele.
the variances, there's not that much difference between the variances.
The second QQ plot, it's a bit more off. So be used.
Daniel, can you shoot the birds?
No. Well, yeah, it looks like it's okay.
Huh?
I think the QQ plots are good.
I think the first one so is the correct answer.
Yeah, I think so.
What do you think, Isai?
Yeah, I got to the second one and my computer froze right now. Okay, it's working. Let me just do the last one right now. Yeah, they're all normal, I would say, and the variants aren't very far from each other. So, has been met, and it's safe to assume each group comes from normal distributed population. Yes. Okay.
I hear you really low, Isai.
Oh, can you hear me right now?
Yep.
Okay. So I just said that I see what you guys said. I think it's the first one.
Okay, cool. So the next question is question 15. Run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51. that F 16.074, yeah, and that P 0.000 with a level of significance equal to 0.05. What conclusions can you draw? We have sufficient evidence to claim that all three hot dogs types have the same mean number of calories. No. We do not have sufficient, no. We have sufficient evidence to claim that all three have a different mean number of calories. We have to claim that at least one of the hot dog types has a different mean number of calories.
Yeah,
I would go with the last one.
I will say the same, yeah. And it's the variable 3, so the, yes. Okay. 16. Now let's examine the sodium levels. Consider a QQ plot of sodium level for each of the three types of hot dog. You should see that the QQ plot for all three suggests a possible problem with the normalized assumption. The smallest variance is 7,000 blah, 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 and the largest is 10,000 blah, blah, blah. No, it's, yes, 10,000. Have the assumption been met to use ANOVA? Well, if it's already saying that a QQ plot is one of the QQ plot is not good, I think the assumption have not been met.
So it doesn't look like the second variance is like 4 times greater than the first one, the smallest.
Yeah, it's not. So we do not meet the assumption have not been met. I was reading. So the first answer is the wrong one for sure. Then the other says it's safe to assume each group comes from a normal distributed population. So not the second one. It is not. So the third one should be the correct answer. What do you guys think?
Well, let's see. Let's actually see the calories, you know, for the
that's like
for the poultry.
It's not the calorie, Daniel.
Yeah, sorry, the sodium. Yeah, I was getting the sodium data, but I said calories.
Well, it gives already the answer. Like, it tells you that there's a problem in that. So I just trust that thing. And I will say...
Yeah, because it has like almost like two straight lines, like two vertical lines, more than like going. It's not safe to assume each group. So I would say the third one.
I'll say the third one, yeah.
Because it doesn't come from a normal distribution. Is that what you think?
Yes. But it has no problem with the 4-time thing.
And then the p-value, do you guys have 0.179?
Wait, I haven't.
I need to copy it.
I haven't done that yet.
Okay, so the p-value I got is 0.179.
I'm getting there.
Is that what you got, Isai?
That's what I got.
Awesome.
Sorry, did you say the p-value 0.179?
Yes.
I got.
Okay.
So question 18, what conclusion can you draw about the mean sodium levels of the three types of hot dogs? Use a level significance 0.05. So we are higher than 0.05. It's opinion you claim that all three hot dogs types have the same mean sodium level.
Well, the only one that says that we don't have sufficient evidence is the second one.
Yeah.
So.
Okay.
I would say it's the only one that it's actually stating what we're doing. Like, we don't have enough evidence.
Okay, you guys want me to submit?
Reject. Yeah, sure.
Okay, okay.
Guys, we got it.
All right.
Yes.
Did it.
Good job. Well, we let you go.